Good morning, class. Today we are starting a new unit in Algebra 2, and it is the rational function unit. So to start off today, we have a couple goals, and the goals are one, to be able to identify what exactly is a rational function, and then to simplify rational expressions. And then we are going to go a little bit farther and talk about some restrictions on the domain that they have. So we're bringing up a lot of old concepts today that I told you would constantly come back. Those concepts being factoring and domain. So before we start off, we're going to warm up. We're going to look at these three different functions. And I want you to describe some similarities and differences of the following functions. So take a moment and think. All right, hopefully your moment's up of thinking. So you're describing some similarities and differences of the following functions. So some things you could have said is the number of terms. Notice this has 3 terms, this has 4 terms. This is kind of weird. It's got like 1, 2, but then on the bottom there's 1, 2, 3 terms. This is a little different. You could have also talked about degree. The degree here is 2. The degree here is 4. Again, this is a little different. We've never seen this before, but you're going to want to say maybe the highest degree, the highest power is 2 here. What else can you say? Well, we know this is a quadratic. We had our first function or our first unit in Algebra 2 about quadratics. This looks like a polynomial because it is a polynomial. We just finished up a unit about polynomials. And again, this one is out of place. So there's a reason why this is out of place. And the biggest thing that makes it out of place is this big fraction bar. And this big fraction bar, remember fraction bar also indicates division. So this is division of 2 polynomials. This right here is called a rational function. This right here is how all of the functions are going to look in this unit. So how do we describe a rational expression, a rational function? Well, first of all, expression, we're going to work first with, has no equal sign. But a rational expression is the division of 2 polynomials. So you have a polynomial up here, you have a polynomial down here. The division of them in one kind of expression is a rational expression. So we are going to see this format in the following. Now, a little more to our warm-up. I want you to recall these 2 problems from the Algebra Review unit. So take a moment, dig back in your brain, and complete number 1 and 2. You're just simplifying these 2 expressions. Okay, hopefully your moment's up. These have a lot to do with exponent rules. So if we recall exponent rules, we have numbers, first of all. So 5 over 15 is really 1/3. So we have a 3 on the bottom. We have an x squared up top and an x to the 4th on the bottom. So remember, we take the 2 and subtract the 4. So 2 minus 4 is x to the negative 2. And then we have a 5 and a 1 for the y. So 5 minus 1 is 4. We look at this and we say, hey, no negative exponents. That must go to the bottom. So when you are finished simplifying, this turned into this. For this one, there's no numbers, so there's still the 2 on top. You have an M10 and an M10. What happens when you do 10 minus 10? You get 0. Or, so to say, these 2 cancel out. Then you have an n squared minus an n, so you have an n up top. You have a P and a Q. Those don't have any partners. So that's what happens when you simplify this. These are all monomials. They're one terms, even though there's two variables here and a constant and two variables here. And there's three variables here and three variables here. Because they're not separated by plus or minuses, these are all monomials. So when you do a monomial divided by a monomial, you have no problem crossing out and doing the subtraction of powers. Again, these are all monomials divided by monomials. You know how to do these. But I don't want you to forget how to do these. But this is not how you simplify when they are not monomials. And they have multiple terms in the numerator and denominator, like up here. This you can't do x squared and cancel x squared because there's multiple terms. So we are going to use this new process when there are multiple terms in the numerator and denominator. Again, we cannot just cancel the terms if they are separated by operations. So you can't just cross out the sevens. You can't. Those adding and subtraction symbols make them married to those things. So you can only cross them out if you see exactly an x plus 7 here and an x plus 7 here. Again, you see an x plus 7 here and an x plus 7 here, but this one's also attached to an x squared. So these don't just get canceled out. Again, over here, the x's don't just get canceled out because x plus 7 is one thing together and x is one thing. So you can't cancel them out unless they're not separated by the plus and minuses. So here are the steps that we use to get rid of things like this. So there's 3 simple steps, and you know how to do each step individually. So there's nothing really new we're learning here. The first step is to factor. The second step is to restrict. And we're restricting the domain. And we'll talk about what this means in a second. And the last one is to eliminate. So now we're going to talk about what it means to restrict the domain. And the reason for step number 2 is that fractions are considered undefined when the denominator is equal to 0. So remember something like this, 1 over 0. This is undefined. My math teacher back in the day used to say, if you see a 0 on the bottom, your paper bursts into flames. So you can't have 0 in the denominator. And since we don't want this to occur, we have to list the numbers that would give a 0 in the denominator. And we call them restrictions. So for example, if our denominator is x plus 2 and x minus 4, we have to say that x can't equal -2 or 4. Because if I plug -2 in here, I get 0 times something. 0 times something is 0, so the bottom's 0. And that's a big no-no. If I plug 4 into here, that means this is 0. So 0 times whatever this is 0. We have 0 in the denominator. My equation explodes. So we have to write these domain restrictions. Now, we are used to writing domain something like this, where it's like, oh, negative infinity to -2, not including 2, union with -2 to 4, not including 4, union with 4, to infinity. So instead of writing it the long way, because all this is saying is all the numbers but -2 and 4, we are just going to write it as x can't equal -2 and 4 for now on. So that's restricting the denominator. Just a little heads up if you haven't realized it already. all you're doing is to restrict the denominator. First of all, you're only doing the denominator, not the numerator. You're just taking the 0 of the factor, which makes sense because if you took the 0 of the factor, that means you have 0 underneath. And 0 underneath is bad. So let's get into these actual problems so you can see the work in action. So we're going to look at example 1. And again, I just got rid of my steps, but my steps are really easy. It's 1, 2, 3 steps. The first step is factor. The second is restrict. And the third is eliminate. So when I say factor, you're going to factor the top and you're going to factor the bottom. So for this one, if I look at the top, this needs to be factored by factoring out the GCF. So I see 4x squared minus 12x. They both share a 4 and an x, which leaves me with an x minus 3. So I factored the top. The bottom, not factorable, it's just x minus 3. So I'm going to put x minus 3. Now I'm going to restrict. So I put r right here so we remember to restrict. We're going to restrict and say, okay, what number can x not be because we don't want 0 in the denominator? Well, this is x minus 3. So if x was 3, 3 minus 3 is 0. We get a 0 on the bottom. That would be really bad, so we have to note that. Now we're going to eliminate. So because we're simplifying, we're reducing, we're just going to eliminate the things that are the same. So this x and this x can't be canceled because this x is married to 3 by a minus sign. So that means I need to find exactly x minus 3 to cross out. The top happens to have an x minus 3 exactly to cross out. So eliminate just means cross out the common factors, which leaves me with 4x. So I simplified and got 4x from this huge thing. And I noted that x can't equal 3. This is for later on domain and graphing. Let's do it again. Example 2. First, we want to factor everything we can factor. So the top, I can factor out an 8, so I get an x minus 10. The bottom, I can factor out a 2, so I get an x minus 10. We are going to restrict the domain. So 2 is a factor in itself, and 2 isn't attached to an x, so we don't need to restrict anything because there's no x there. 2 will never become 0. But x minus 10, if x was 10, this quantity could become 0. So if x is 10, bad things happen. So we have to restrict. Now we're going to eliminate. So we're going to eliminate the common factors. So first off, x minus 10 and x minus 10, those are exactly the same, so I can cross them out. And then I have an 8 divided by 2. So 8 divided by 2 is 4. So in the end, if I have this, all of this just gets simplified to the number 4. Do it again. Factor. So I have 3x minus 4. Well, I can't do anything with 3x minus 4. There's no GCF. It's not a quadratic, so I'm not factoring, simple factoring, magic dot factoring, all of that. The bottom is 9x squared minus 16. So first I'm going to look for a GCF. Does 9 and 16 have any number that goes into both of them? No. But it should dawn on you that 9x squared minus 16 is a difference of perfect squares. We know how to factor difference of perfect squares. How do we factor a difference of perfect squares? We put 2 parentheses. The square root of 9 is 3. The square root of x squared is x. We put those there. One gets a plus, one gets a minus, and then the square root of 16 is 4 and 4. So we factored. Now we have to restrict. So again, we have to look at the factors in the bottom and say, what are their zeros? Because that's not possible for them to be. So 3x plus 4 is a negative 4 over 3. And 3x minus 4 as a positive 4 over 3. Again, in this problem, nothing new happened that we haven't learned. We've learned how to factor difference of perfect squares. We've learned how to find zeros of factors. And last step is eliminate. Now we know how to cross things off. So this is thought of as married, 3x minus 4. So I need to find the exact thing that says 3x minus 4. This happens to have 3x minus 4, so these cross out. There's nothing left on the top. But it's weird if we just write this. So what do we put on the top? Well, technically, when we cross things out, like what is 4 divided by 4? The same thing over same thing. That's 1. What is smiley face over smiley face? That's 1. Anything divided by itself is actually 1. So this divided by this is a 1 on top. We haven't written the 1 before because we don't need to write 1 unless it's missing something to write on top. So that's its fully simplified. There's its restrictions. The only way these problems get harder is with more difficulty of factoring, which again, we've gone through all the factoring ways. So these shouldn't be difficult for you unless you need a big factor refresher. And that's something you should take upon on yourself because we've been factoring since September. So now you're going to try 4 through 6 on your own at some point. But I'm going to do 7 with you. Let's look at 7. So we're going to follow our steps to factor everything. The top, I could take out a 4, so I have an x plus 6. So that's a factor to the top. This is x squared plus 4x minus 12. I note that there's nothing next to the x squared, so it's simple factoring. That's an x and an x. So I need factors of negative 12 that give me positive 4. So that looks like positive 6 and 2, negative 2. I need to restrict the bottom, so x can't equal, well, this is x plus 6, so x can't equal negative 6. This is x minus 2, so x can't equal positive 2. Then I need to eliminate. Well, there's an x plus 6. There's an x plus 6. Note, I'm not reducing the 4 and the 2 because negative 2 it's married to x. So I can only cross out x minus 2 if I had another x minus 2. So this is just 4 over x minus 2. Number 9 looks a little more complicated. It's not. It's just more factoring. So the first step is factoring. So I look at the top and I see, all right, this is definitely going to be simple factoring. So that's an x and an x, and I need factors of 27 that give me 12. That's 9 and 3, because 9 times 3 is 27. 9 plus 3 is 12. On the bottom, there's got to be more factoring now. So the first thing I notice is they all have x. So I'm going to factor out the GCF, the first step of factoring. I also notice I can divide all of them by 2. So now here I'm left with an x squared. Here I'm left with a 6x. And here I'm left with a 9. Note, I didn't factor all the way yet, so I'm going to do another row of factoring. Because this now can be factored as an x and a plus 3 plus 3. Now I'm fully factored, so I'm on step 2 where I can restrict. So the first thing we have to look at is, this just says 2x. So what makes just 2x turn into a 0? Well, 2 times what number equals 0? Well, if x was 0, this whole thing turns into 0. So that means x can't equal 0. Now this is x plus 3 and this is x plus 3, so that both means negative 3 also messes those up. Now we're eliminating, so I have an x plus 3 here, so goodbye to at least one pair. Now, this says x plus 3, this says x plus 9. Do not try to cross the 9 out and make it a 3 because x plus 9 is attached to each other, can only be crossed out if I have another x plus 9. So that can't happen. I also can't cross out these x's because x plus 9 is attached to each other. You can only cross it out if it was x plus 9. So this is as far as you can go. So that's how you're going to write it. We're going to do one more. And as I do that one more, I want you to note that I want you to cross off 15. All right, let's look at 14 because we haven't seen one type of factoring that we've talked about, or technically two. We haven't seen magic dot, and we haven't seen the difference or sum of perfect cubes that we talked about in the polynomial lesson. So again, the steps aren't changing. We got to factor, we got to restrict, we got to eliminate. It's all about how we factor. This first thing we're looking at, the first thing you look for factoring is taking out a GCF. So we have a 2x cubed plus a 250. We could take out a 2. So 250 divided by 2 is 125. If we look at the bottom again, 2, 10, 50, we can take out a 2 to make it an x squared minus 5x plus 25. Still not fully factored on either numerator or denominator because x cubed plus 125 is a summation of perfect cubes. So we talked about SOPs, remember? So you take the perfect cube of the first, you take the perfect cube of the second, and then you square the first, take the opposite product of the two, and then square the second. So that's your top. Your bottom, if you notice, is not factorable, but it looks identical to the trinomial that you got on the top. So in this case, because this isn't factorable, there's actually no real number that we need to worry about for x. So we don't have to write a restriction. And these guys get crossed off. And these guys get crossed off, leaving you with an x plus 5. I do want to draw your attention to these, but I'm not doing them. 2x squared plus 7x plus 3, when you go to factor, you're going to have to use magic dot. Over here, make sure you're always looking for the GCF first. Remember all these rules of factoring. That's going to be the only difficult part of this, and it shouldn't be difficult because, again, we've had all year together where you should have asked questions if you were still unclear on factoring. So now we're going to end this lesson with a ticket to leave. So here's 2 problems I want you to complete for your ticket to leave, so I know that you understood this lesson. All right, I'm glad you're back from your ticket to leave. Let's go over this all together. So we're just doing the same thing we did before. I even wrote a spot for your answer on the bottom and your restrictions. So the first step is to factor. So I notice on the top GCF first of 2. So I have an x squared plus a 2x minus a 3. The bottom also has a GCF situation going on, x squared minus 5x plus 4. These are still not fully factored. I can factor both top and bottom. So the first one, I have an x and any factors of -3 that give me +2. So that's a +3 minus a 1. The bottom is x, and I need factors of 4 that give me -5. So that's a -4, -1. Now I need to restrict the domain. So I'm looking at the bottom and saying, okay, well, this is the first factor. It's just x. Well, just x means x can't equal 0. X minus 4, x can't equal +4. X minus 1, x can't equal +1. There's my restrictions. Now I'm doing eliminating. Bam, bam. And here are the survivors. Do not distribute these back in. Because remember, to do it, I wanted to factor it out first. Here's another one. It looks kind of weird, but no worries. Factor the top. Well, the top can't be factored. Factor the bottom. I'm taking out a GCF. I'm left with an x plus an 8. I need to restrict the denominator. Here's the denominator. So if x was to be 0, that's an issue. So x can't equal 0, and the x plus 8, x can't equal negative 8. Now, this is a straight up x, this is a straight up x, so those can cancel, leaving a 1 on top, leaving an x plus 8 on bottom. Don't forget to fill that 1 in. Don't just carry the x plus 8, because the x plus 8 as a numerator opposed to denominator is a whole different number, right? Like, it's the same idea as saying 4 and 1/4. If you gave me the answer of x plus 8, that's completely different than the answer of 1 over x plus 8. You don't want $4, or you want $4 opposed to a quarter, right? Like, they're big different values. So your final version is 1 over x plus 8. And that is the lesson for today.